Good morning, dear students. Welcome to the first video session. Today's topic is acids, bases, and salts. Democritus had rightly said, quote, "We think there is color, we think there is sweet, we think there is bitter, but in reality there are atoms and a void." Unquote. Today we are going to talk about what is an acid. The word acid comes from the Latin word acidus, meaning sour. The sour taste of some food is due to the acids that they contain. An acid, how do I define an acid? An acid is a chemical compound which, when dissolved in water, produces hydronium ions or H positive ions, the only positively charged ion, and a negative ion. Now we move on to classification of acids. Acid can be classified in different ways. Some important ones are: firstly, classification on the basis of the source. Second, classification on the basis of the concentration of acid. Third, classification on the basis of strength. Fourth, classification on the basis of basicity. And lastly, classification of acids on the basis of their composition. Classification on the basis of source means from which they are obtained. It can be classified into two major categories. One is organic acid and the second one is inorganic acids. Let us discuss organic acids. Organic acids are derived from organic substances or living organisms. For example, vinegar is the source of acetic acid. Sting of red ants and bees is the source of formic acid. Sour milk is the source of lactic acids. These acids contain as one of the constituent atoms and are weak acids. Now let us discuss inorganic acids. Inorganic acids are also called mineral acids. They do not contain carbon except carbonic acid. The molecular formula is H2CO3. Examples: hydrochloric acid is obtained from chlorides, sulfuric acid is obtained from sulfates, nitric acid is obtained from nitrates. Now we move on to classification on the basis of the concentration of acids. One is concentrated acid, the other is a dilute acid. A concentrated acid has relatively high percentage of hydrogen ions in the aqueous solution. What does it mean? It means concentrated acid contains high percentage of acid and less percentage of water in it. For example, concentrated hydrochloric acid, concentrated sulfuric acid, concentrated nitric acid, etc. In short, we write CONC, conc HCl, meaning concentrated hydrochloric acid. The second one is dilute acid. A dilute acid has relatively low percentage of hydrogen ions in water. That means it contains more percentage of water and less percentage of acid in it. For example, dilute hydrochloric acid, dilute sulfuric acid, dilute nitric acid. So we write DIL, dilute HCl. It means dilute hydrochloric acid. Now, the next is classification on the basis of strength. The strength of an acid is defined as the amount of hydronium ions furnished by 1 mole of an acid in water. On the basis of strength, acids are of two types, strong acids and weak acids. Meaning, when an acid is dissolved in water, how much of or how many hydronium ions or H positive ions are produced in its aqueous solution. So, let us discuss strong acids. What do you understand by the term strong acids? Strong acids completely ionize in aqueous solution, producing high concentration of hydronium ions. For example, sulfuric acid, hydrochloric acid, and nitric acid. These are all strong acids and they are mineral acids. So when you dissolve them in water, it produces maximum concentration of hydronium ions. The second one is weak acids. They ionize partially in aqueous solution and thus they contain ions as well as molecules of the acids. Organic acids are generally weak acids, hence they do not ionize fully, only partially. So they are called weak acids. Now we move on to classification on the basis of basicity. First and foremost, what is basicity of an acid? Basicity of an acid is the number of hydronium ions produced by the ionization of one molecule of the acid in its aqueous solution. I repeat, basicity is the number of hydronium ions, or you can say H positive ions, produced by the ionization of one molecule of the acid in its aqueous solution. So, on the basis of basicity, we can classify acids into three major categories. Firstly, monobasic acid, secondly, dibasic acid, and thirdly, tribasic acid. Let us discuss the first one, and that is monobasic acid. In it, one molecule of an acid produces one hydronium ion on ionization in water. Examples: hydrochloric acid, hydrobromic acid, acetic acid, formic acid, nitric acid. These are a few good examples of a monobasic acid. Look at the equation. HCl plus H2O gives H3O positive hydronium ion and a chloride ion which is negatively charged. It yields only one hydronium ion. Hence, it is called a monobasic acid. The second one is a dibasic acid. In it, one molecule of an acid produces two hydronium ions on ionization in water. For example, sulfuric acid, carbonic acid, sulfurous acid. These are few good examples of dibasic acids. Dibasic acids, they have two replaceable hydrogen atoms per molecule. They form two series of salts, namely an acid salt and a normal salt when reacted with a base such as sodium hydroxide. Always remember, dibasic acids, they dissociate in two steps in water to produce two hydronium ions. Now let us move on to tribasic acids. Tribasic acid. In it, one molecule of an acid produces three hydronium ions on ionization in water. For example, phosphoric acid, H3PO4. Then we have boric acid, H3BO3. They dissociate in three stages in aqueous solution to produce three hydronium ions, hence they are called tribasic acids. Classification of acids on the basis of their composition, or you can say classification on the basis of elements present in them. On this basis, we can classify into two major categories. Number one, oxyacids. Number two, hydroacids. Now, what do you understand by oxyacids? Oxyacids, they contain oxygen along with hydrogen and another non-metallic element. For example, sulfuric acid, H2SO4. Nitric acid, HNO3. Phosphoric acid, H3PO4. Look at it. They contain oxygen along with hydrogen and another non-metallic element, maybe sulfur, maybe phosphorus, maybe nitrogen. The next one is hydra acids. They contain hydrogen and a non-metallic element other than oxygen. Example, hydrofluoric acid, HF, hydrochloric acid, HCl, hydrobromic acid, HBr, hydrogen sulfide, H2S, and hydroiodic acid, HI. That brings us to the end of today's lesson. Believe me, chemistry is the melodies you can play on vibrating strings. If you ignite passion for chemistry. Thank you.